Now generally when you are solving the problem, we go up to maximum 6th order. If at all 6th order characteristic equation is available, let us see what are the possible calculations. Now take this example. So it's a generalized. Now characteristic equation Q of S is equal to, let us say I have A naught S power 6 plus A1 S power 5 and A2 S power 4. Now A3 S cube and A2 A4 S square, and we have A5S plus A6. So this is the complete characteristic equation of your system. Now, so this characteristic equation we form the Routh array. We just now seen how to form the Routh array. Now let us take the left side rows. What are the rows we have? S power 6, S power 5 and so on up to S power 0. So if you count total number of, we have 7 rows. So all 7 rows element we should fill. Now look at, out of 7 rows, 2 rows call element directly we take from the characteristic equation. We can see here S power 6, S power 5, I am taking A0, A1, A2, A3, A4, A5, A6. So I am starting from the first element, highest degree A0. Then you fill the next element. Then you go like this and come down, go like this, come down. So it is continuous up to the last element A6. So 2 elements are over. Next, so we have S power 4 row. I am just defining it as a B1, B2, B3. That's it, right? So don't go beyond the B3 for this S power 4. Next, S cube. S cube will have C1, C2. Only 2 elements to be calculated. Now for S square we have D1, D2. Again only 2 elements to be calculated. And S power 1 we have only E1, 1 element, and S power 0, F1, 1 element. Now once we fill all the elements like this, let us see the calculations. Now in the calculations, the first one is B1. We know to calculate B1 we need 4 elements, A0, A1 and A2, A3. So directly I am going to write B1 as your A1, A2 minus A3, A0 by A1. That is the B1 calculation. And when it comes to B2 calculation, we have A1, A4 minus A5, A0 by again A1 only. Remember, the first element is important. So when you calculate, I am starting with the first element and divided by the first element, right? Even the divided also by the first element only. First element calculations are important in Routh array, any Routh table or Routh array. Now coming to B3 calculations. When you look at the B3 calculations, interestingly, we have A0, A1 and A6 and there is no element. Therefore, you can take it as 0. Now, what will be the calculation? We should start from A1, A1, A6 minus B0, A0, sorry, 0 into A0. There is nothing is there. So, 0 into A0 divided by A0. So, divided by A1. So what you will get here, you will get directly this element is A6. Means, so whenever there is element and below if you find any 0, that element is carry forward here. So you can look at the arrow. So from there to here you can carry forward. So you need not do the calculation for B3. B3 directly it is A6. Therefore in this row, how many elements to be calculated? If the highest degree is 6, only B1, B2. And the formula is also very simple. Your A1, A2 minus B3, A3, A0 divided by A1. And B2 is A1, A4 minus A5, A0 by A1. Similarly, we will see how to calculate C1. When you calculate C1, it is B1, A3 minus B2, A1 divided by B1 alone. Because B1 is the first element. Similarly, C2 calculations. Let us closely observe all the calculations. So C2 is, I have B1 A5 minus B3 A1 divided by B1. So in this row I have only 2 elements, C1 and C2. Similarly, you can calculate for the next S square D1 D2. What will be D1? We can write C1 B2 minus C2 B1 divided by C1. And D2, again if you want to calculate D2, look at that. And above already we have B3 below nothing is there, therefore that will be directly carried forward. So what will be D2? D2 is directly B3, need not calculate. Similarly S power 1, there is only one element E1. What will be E1? So from C1, C2, D1, D2 you can calculate E1, that is a D1 C2 minus D2 C1 by D1, that will be the E1 calculation. Then finally F1. Again if you want to calculate F1, and if you look at the next row, the last element is 0, therefore the D2 is a carry forward. What happens here? A6 is carry forward to B3 and B3 is carry forward to D2 and D2 is carry forward to F1. So out of 9 elements, we need to calculate only 6 elements, 3 are directly available and the first 2 elements also available. So this way you can easily calculate the elements and you can fill the complete Routh array and finally investigate or observe the first column elements polarities. If all the elements having same sign, system is stable. If you have any sign changes, system is unstable. Number of sign changes gives number of closed loop poles lying in the rate of the S-plane or number of roots of the characteristic equation are having positive real part. To understand the concept of Routh-Harvey stability criterion, let us look at 1 or 2 problems as examples. Here goes the first one. Find the stability of the system whose characteristic equation is given by Q of S is equal to 2s power 4 plus 5s cube plus 5s square plus 2s plus 1. So this is the characteristic equation of the system. We need to find the stability of the system using RH criteria, Routh-Harvey criteria. Now we know already how to form Routh array. So what is the highest degree here? 4. Therefore, I will take a Routh array directly. Now the highest degree is s power 4, s cube, s square, s power 1, s power 0. So these many number of rows I have. Now I said the first 2 rows must be filled from the characteristic equation and other rows elements to be calculated. Now let us see how to calculate with the numerics which are available to us. Now we have already characteristic equation and the quotient of s power 4 is 2, therefore the first element is the 2. The next element is 5, so I am taking the second row, first element, then again the one more element is 5, one more element is 2 and next element is 1. So all these 5 elements we can enter like this. I said you have to take drop down and again go like this. So like this we need to follow, or else all the even terms we should place. If the highest degree is s power 4, all the even s power terms coefficient should be written like this, and or the odd term, because we have s cube means odd term coefficients will be written in the second column. If at all, if the highest degree is s power 5, first we will have all odd terms and then we will have all even terms. Otherwise it is better always start with the first column, first element, then write the next element below that and go to the next element above that, again below, above, below. This way we can fill the first 2 elements very easily. Then the next is s square. So if you want to find the s square element rows, look at how to calculate this. So above 2 rows, 4 elements I should take. What are they? 2, 5, 5, 2 I have. That means I have A0, A1, A2, A3. We know the formula to calculate this. This is something like B1. What is it? B1 calculation? It is A1, A2 minus A3, A0 divided by A1. Now here 5 into 5 minus 2 into 2 divided by 5. So if you do the calculation, you will get it as 4.2. Now in this case the next element is B2. Now this B2 you need not calculate, because in above row we have the last element 0 and above that we have 1. That 1 is directly carry forward here. Okay, so B1 is calculated as 4.2, B2 is here, it is 1. Coming to the s power 1 row. In s power 1 row, let us say this is C1, and how do you calculate that? Using the above 2 rows we can easily calculate. How can you write this? C1, it is 4.2 into 2 minus 1 into 5 divided by 4.2. So that gives us it is 0.8. Calculations are very important. I am always starting from the first element, multiplying the opposite element, then minus the other 2 element divided by the same element. Therefore it gives us 0.8, that is a place only. And again the last element you need not calculate, that B2 is carry forward here, you will be getting D1 as 1. Now what I want to look at the first column elements alone. So you take first column elements and write here. When you write here, we have 2, 5, 4.2, 0.8 and finally 1. So values are not important, signs are important. All are having positive sign. Then from 2 to 5 there is no sign change, 5 to 4.2 there is no sign change, 4.2, 0.8 there is no sign change, and 0.8 to 1 there is no sign change. Therefore number of sign changes is equal to 0. What is the highest degree here? S power 4, which means there are 4 roots of the characteristic equation. We know the roots of the characteristic equation are closed loop poles. So I want to write in terms of the poles only. Therefore total number of poles is equal to 4. I need to write the summary of it. So total number of poles is equal to 4. Then number of sign changes 0. What it indicates number of sign changes? Number of poles lying in right half of the S plane. Therefore how many number of poles right of the S plane? 0, because no sign changes. So therefore what will be the left of the S plane? So total 4 and none is in the right of the S plane. Therefore all the poles lie in the left of the S plane. Therefore number of LHS poles. LHS means left half of the S plane. RHS means right half of the S plane is 4 now LHS poles. Therefore the system is closed loop system is stable.